Here we've got a metal disc, and it's going to be exploding into 3 flying pieces. The first piece, which I've drawn on the picture below, has a mass of 2.4 kilograms. So you imagine this disc is going to break apart into these 3 shapes. And the 2.4 kilogram piece is going to fly directly north or upwards at 10 meters per second. The 2 kilogram piece is going to fly directly east at 12.5 meters per second, as shown in the diagram below. And the last piece, the goal is to find its final velocity, which includes the direction. So this is my initial drawing. This is what's actually happening, but we want to use conservation of momentum because it's an explosion. Collisions and explosions are always conservation of momentum. Now the total momentum before the explosion, because it tells you it's initially at rest, is 0. And I've got 3 different pieces moving after, and they each have a momentum. So when you add up P1 plus P2 plus P3, those 3 should add up to 0. So when we do the trig method, we're going to do a tip-to-tail diagram where the resultant is 0. In other words, those 3 vectors are going to make a closed triangle where there's no gap and no resultant at the end. So let's first of all figure out our individual momenta. Now momentum is just mass times velocity. So very, very simple to calculate. 10 meters per second times 2.4 kilograms gives P1 a momentum of 24 kilogram meters per second. Similarly, we know P2 because we know its mass and its velocity. 2 kilograms times 12.5 gives us 25 kilogram meters per second. And notice those are at 90 degrees to each other. So when we use the trig method, it's likely this is going to be fairly straightforward. So the trig method is telling us that those 3 vectors have to be added together tip to tail. So let's go for it and make our picture. So P1 straight up, and its value is 24. And at the tip of P1, I'm going to start P2, and it's to the right, and its value is 25. Now let me just move that one, P2, out of the way so we have a better looking picture. Okay, plus P3. Now P3, I start at the tip of this vector here, the tip of P2, and we know it's pointed in the direction of its velocity, which we're guessing is down to the left. Regardless, I know I have to close the triangle because it's got to add up to 0. So P1 tip to tail plus P2 tip to tail plus P3 makes this closed triangle as follows. And we're trying to find the magnitude and direction of P3. Okay, 90-degree triangle. We can certainly do Pythagoras. So P3, the magnitude of it, will simply be 24 squared plus 25 squared, all square rooted. And that will give me a magnitude of 34.7 kilograms times meters per second. If I want to know a direction of P3, this little angle right in here, I can do tan theta. So I'll do that in pink. Tan theta is opposite, which is 24, over adjacent, which is 25. And when you solve that for theta by going tan inverse, you get 44 degrees, and you can see that it's south of the west line. So we've got our magnitude of momentum and we've got our direction. Now all we need is the velocity. Well, remember momentum is simply mass times velocity. So mass 3 times velocity 3 will be that momentum. Mass 3 is 1.4 kilograms times V3 equals 34.7 kilogram meters per second. And you end up getting V3 is 24.8 actually, meters per second, which rounds up to 25 meters per second at an angle of 44 degrees south of west. Now that's the trig method. Now let's look at the component method. I'll push aside the trig method so we have some room. Okay, with the component method, we simply do the equation that we've established, the original momentum equation. We do it once in the x and once in the y. So let's start with our x direction. 0 equals p1x plus p2x plus p3x. Now 0 equals. Now p1 was 24 kilogram meters per second and it was straight up, so it has no x component. So that's going to be 0. P2 is all in the x, so it's going to be 25 kilogram meters per second. Plus P3 in the x. And when I solve that for P3 in the x, I get negative 25 kilogram meters per second. Do the same thing in the y. 0 equals P1y plus P2y plus P3y. P1y, well, 24 is all in the y. P2y is 0 because there is no y component. And we've got to solve for P3 in the y. And we know that all adds up to 0. So when I solve this one for P3, I end up getting P3y is negative 24 kilogram meters per second. So now I know my x component and I know my y component, and as usual with this method you do tip to tail of my x and y and solve for the hypotenuse. You'll notice this is exactly the same as our trig method now. So we've got 25 to the left is my x component and 24 down is my y component. So my overall value of P3 will be the hypotenuse. And if I do Pythagoras, I get the same answer as I did before. And P3 will end up becoming 34.7 with Pythagoras. Similarly with the angle, I go tan theta is opposite over adjacent, or 24 over 25. I get the same angle as I did before, 44 degrees south of west. And then when I divide this by the mass, I get the same velocity. So they're very, very similar, two different approaches, however.